way of expressing concentration of solution is molarity. It is symbolized by M and is also known as molar concentration. The unit for molarity is M, or can also be mole per liter. Molarity is defined as the number of moles absolute per liter of solution. Now, for those who just heard about the mole, it is not an animal nor a skin mark. In chemistry, it is a standard scientific unit for measuring large quantity of very small entities such as atoms, molecules, or other specified particles. As you can see here in the screen, mole can be shortened as MOL. So that's the unit used for mole. Now we will have a detailed discussion about this as we discuss further about the mole. Now let's go back to molarity. Molarity, just like any other methods of expressing concentration, is using also its own equation. Let me just change it into black. Okay. Now the equation is M is equal to N divided by V. So what does M stands for? M is equal to the molar concentration while the N is equivalent to the moles absolute while V is the liters of solution. So take note that it is always expressed in liters of solution. So you may want to copy that on your notebook so that later you'll be able to recall the formula for molarity. Now let's go to the sample problem. Let me write first a sample problem. Let's have sample problem number 1. Two moles of sodium chloride, NaCl, is dissolved in 2 liters of solution. What is the molarity of the solution? Okay, so let me just read once again the problem. Problem number 1. 2 moles of sodium chloride is dissolved in 2 liters of solution. What is the molarity of the solution? So in this type of problem, you need first to identify the given as always. So let's identify the given. Okay, so the given are as follows. We have 2 moles of NaCl, and we also have 2 liters of solution. So obviously 2 mole of NaCl is the mole absolute, while the 2 liters is obviously the liters of solution. So what is being asked in the problem? We need to compute for molarity, the M. And so we will be using now the formula that I gave you a while ago. So the formula is, so let's have first the solution here. The formula for molarity is M is equal to N over V. So let's now substitute the formula. So let me use this part of the screen. M is equal to N over V. So substituting the formula, N, we have here the N, which is equivalent to 2 moles divided by the V, which is the 2 liters. So 2, wait, let me erase that one first. It's not 2 mole, it's 2 liters. 2 liters. Okay, so 2 divided by 2, the answer is 1. So 1 is the answer. It could be expressed as 1 mole per liter or just 1 m. So we are done now with problem number 1. So most of the problems are not expressed in moles. Usually it is expressed in grams. So this will be encountered in our second problem. So let me just erase problem number 1. And let me write now problem number 2. So for problem number 2, we have here 15 grams of sodium bromide is dissolved in 400 ml of solution. What is the molarity of the solution? What is the molarity of the solution? Okay, so once again, let's read. 15 grams of sodium bromide is dissolved in 400 ml of solution. What is the molarity of the solution? So let us identify first the given and the problem. We have 15 grams of sodium bromide and 400 ml of the solution. What is being asked in the problem is the molarity. This type of problem requires you to convert first the gram into mole and the ml into liters, because remember that in order for us to solve molarity, there is a need for you to use the moles of solute and the liters of solution. So that's the first thing we need to do in this problem. So let's start now with our solution. So we have 15 grams of NaBr. We need to get first the molar mass of sodium bromide. When we say molar mass, it's just the atomic masses of the elements sodium and bromine. And you are correct, we need to get our periodic table of elements in order for us to know the atomic masses. And so let's have our periodic table of elements. Okay, so we have here the periodic table of elements. Let's start first with sodium. So I have here the sodium, and we are looking for its atomic weight. And here's the atomic weight. We have 22.9897. So we need to copy the atomic weight, 22.99. Let's just round it off. And then the second one is bromine. Let's look for the bromine. Bromine is found, wait. Okay, here's the bromine. So let's click bromine. And that's not bromine, that's krypton. We need to look for bromine. Okay, we now have here the bromine, and we are looking for its atomic weight. Okay, bromine has atomic weight of 79.90. So let's have here, let's write bromine 79.90. Okay, so let's go back to our whiteboard. Okay, so we need to add the atomic masses of sodium and bromine. So remember, sodium has an atomic mass of 22.99, and bromine has an atomic mass of 79.90. There is only one sodium and only one bromine, so you just have to multiply it by 1. Let me write it here. Okay, so the answer is just the same. It's 22.99, and we have 79.90. So adding these two up will give us, okay, 12, 7, 8, 9, 10. So that gives us 102.89 grams. Gets. Okay, so I'm going to erase. I'll just leave here the 102.89. Okay, careful. Okay, so 15 grams. 15 grams of sodium bromide is equivalent to 102.89 grams. But we are not yet through. We will just need this in order for us to convert 15 grams into the number of moles. And this is how we convert 15 grams. 15 grams NaBr is equal to, we have here 102.89 grams is equivalent to 1 mole of NaBr. So usually, the desired unit is actually found on top. When I say desired unit, that is the unit you are looking for. That's the unit you want to solve for. That's why it's always found on top, so that we can cancel the grams, leaving us with the unit about mole. So if you are going to solve for it, that would be 15 times 1 divided by 102.89. Now, if you find it very hard to calculate this one, well, we can just use our calculator. Where is the calculator? Okay, here's the calculator. Let's use the calculator to solve for it. Okay, so let me go back. I forgot we have 15 grams divided by 102.89. Okay, so let's use another calculator. So we have 15 times 1 is obviously 15. You can see it from the calculator. And then 15 divided by 102.89, 15 divided by 102.89 gives us 0.1457. So let's just get the two decimal places. That gives us 0.15. Okay, so let's go back to our whiteboard. Okay, so this gives us the answer of 0.15. Now we will be using the unit mole. So you are now ready, and you're able to derive now the mole of the solute. So I'm going to put it here for the solution so that we'll not forget later. Okay, so I'll erase this one now. I'm going to put 0.5 mole NaBr. Okay, let's erase this one and proceed with the next step. The next step now is to convert this one into this one. So it's very easy. You just have to use this one. 400 ml. How many ml are there in 1 liter? So obviously, we are going to put on top the L because that's the desired unit. That's the unit we are looking for. And at the bottom part, we will use the equivalent of 1 liter into ml, and that is 1000 ml. Then we will cancel. So 400 times 1 divided by 1000, that gives us how many? Okay, I want to use the calculator for us to be sure. So 400 divided by 1000 is 0.4. Okay, going back. So the answer is 0.4 liters. So I'm going to write it here, 0.4 liters. And so we are now ready to solve for the molarity of the solution. So using the formula, M is equal to N over V. Let us now substitute the formula. N is 0.15 mole divided by 0.4 liters. Now we will be using the calculator once again to solve for it. Okay, so let's clear this out. 0.15 divided by 0.4, that gives us now the answer of 0.38. Let's round it off to 38, so that's 0.38. 0.38. So that is now your final answer. Okay, we're not yet through. We are moving on into our problem number 3. Let's erase now this one. Okay, for problem number 3, the question is, how many grams of sodium chloride is needed provided that you need to prepare 5 mole per liter out of a 3 liter. Okay, erase. 5 mole per liter out of a 3 liter solution. 3 liter solution. Okay, so let us read once again the problem. How many grams of sodium chloride is needed provided that you need to prepare 5 mole per liter out of the 3 liter solution? Now this problem will need you to manipulate the formula. So let's just first have the formula for molarity. Molarity is equal to N over V. Just like what we did in the percentage by mass and percent by volume, we will be using again a little bit of algebra in order for us to get what we are looking for in here. Because as you can see in our problem, molarity is also already given. We have 5 moles per liter, and we also have here the liters of solution in here, and what we are looking for here is the N, or the number of moles of solute. Okay, so let's go back and erase this one now. And remember our a little bit of algebra. So there is a need for us to cross multiply the two, and that gives us molarity times the volume in liters equal to N times 1. There's no need for us to write the 1 here because it's pretty understood that it's already 1. We are looking for the number of moles in here, and in this case it's already given. So the number of moles is equal to molarity times the volume of the solution in liters. And so let us now start by identifying the given. The given which we already identified a while ago, we have the 5 mole per liter, which is already the molarity, and the 3 liters of solution, which is the letter V. What is being asked is obviously the N, or the number of mole. And so let's proceed now to the solution for the problem. So we'll be using now this formula in order to solve for the N. N is equal to molarity times liters of solution. N is equal to, molarity is here, we just have to copy the 5 mole per liter times the volume. We are going to write here, we have 3 liters. Is there a need for us to cancel? Obviously, we need to cancel the liters. That leads us only to mole. And so, 5 times 3 is equivalent to how many? It's 15 moles. So we now have the answer for problem number 2. Very easy, right? Now it's time for you to answer the worksheets. I will be uploading worksheet number 3.